Welcome to Eko Learners Support for WAEC and NECO candidates. Today, we are having physics and I'll be your instructor for the class. We'll be considering the topic friction. Follow me as we go.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Like I rightly said, we are talking about friction. In this part of friction, we'll be looking at the formula used in solving questions relating to friction and simple problems involving friction. At the end of it, I'll give you some exercises to work with. Don't forget, they ask you what friction is. You should remember that friction is an opposing force. It's a resistive force. It hinders motion. So we are going to look at the calculations that surround this frictional force. Look at what you stand to gain. At the end of this lesson, you should be able to state the formula used in friction. More so, you should be able to solve some problems that is involving friction. Frictional force and normal reaction. Here, I want to show you how to get the formula that we used in friction. Look at this. Frictional force is proportional to normal reaction, which means that frictional force has a direct relationship with normal reaction. Implicit to that, whatever happens to normal reaction happens to frictional force. And normal reaction is a function of the weight of an object. Let's look at it this way. Now, look at normal reaction. This normal reaction is a function of weight. So whatever happens to weight happens to normal reaction. So as weight increases, normal reaction also increases. So since normal reaction is directly proportional to frictional force, implicit to that, the frictional force also increases. So that's why we have it in mathematically. We say F is directly proportional to R. When you remove the proportionality constant, you introduce an equality sign. When you remove the proportionality sign, you introduce an equality sign with proportionality constant. So F equals to nu R. So making this the subject of the formula, you have nu equals to F over R. Here, this nu is called the coefficient of friction. So it's the ratio of the frictional force to normal reaction. So you can see F is frictional force, R is normal reaction. Look at what we are talking about just now. Okay, this normal reaction is acting upwards. Look at normal reaction. Normal reaction is upwards while weight acts downward. Because they are directly proportional, they are equal but opposite. So weight acts downward, normal reaction acts upward. So whatever weight we have is also the normal reaction we are having. And look at it. From frictional force, if direction of motion is this way, then the direction of friction is opposite the way. The direction of friction will be opposite. That means the other direction. So look at it now. If the object is to move this way, frictional force will move the other way. Vice versa. If the direction of motion is this way, the direction of friction will be this way. But since it's lying on a horizontal table, the weight goes down while normal reaction goes up. But in the next one, look at this now. This other side, look at this. You can see that this surface is not horizontal. Look at this surface here. It's not horizontal. But this surface is horizontal. This next surface, look at it, it's inclined. So what you have here is different from what you're having here. Here you can ascertain the fact. Look at this. From here now, this is our normal reaction, R. This is our weight. Our F is equals to nu R. We hold here normal. And then our normal reaction is the same thing as our weight. So which is mg. So I can also say that F is equals to nu mg. Don't forget, the value of my R is mg. But that will not be exactly what we are going to have in the other side. Though we are going to use this formula, but we are going to have the value that is slightly different from this. Look at what I'm saying. Look at what we have here now. From here, you look at this. This is the surface we are considering. Is inclined at an angle theta. So what we are going to have here is that our normal reaction, which is directly opposite this arrow. So our normal reaction now is W sine theta. While the one acting vertically downward is our weight. The same thing happened when we had it on the horizontal surface. If you have it on the horizontal surface, your normal reaction acts downward, which is the same thing as your weight. Your normal reaction acts upward. This is the normal reaction. Your weight acts downward. So normal reaction is the same thing as weight. In this case, the weight still retains its position. But once the surface is inclined, your normal reaction is still at 90 degrees to the surface. So whatever angle you tilt here will be that angle here. So this force is acting parallel to the surface. So you still have it retained, acting parallel to the surface. So if you bring this force here, you're going to have something like this. For this line, for this force, and this angle, this is your theta. So if the weight acting is this is your W, then this is your normal reaction, this is the force is acting horizontally. So from here, using trigonometric ratio, you can easily get the value of F and R. So from here, you're having it as this place is 90 degrees. So it's 90 degrees, yes, this place is 90 degrees. So from here, this place is your hypotenuse. This is opposite, and this is adjacent. So from here, you can get the value of F. So you can say sine theta equals to opposite F over hypotenuse W. So from here, you can say F equals to W sine theta. So this is the value for W. So instead of having F equals to nu R, your F will be replaced with W sine theta. The same thing for your R. Look at it. Your R is adjacent, and then your W is hypotenuse. So you are going to have car. So that will be cos theta equals to adjacent R over hypotenuse W. So R will be equals to W cos theta. So in this place, we are going to have W cos theta. So in this case, if you have F equals to nu R, so your nu will now be equals to F over R. The F given as W sine theta and R given as W cos theta. So the value of W is the same. So W goes for W. You are going to have sine theta over cos theta. So when you have sine theta over cos theta from trigonometric ratio, you know that this is going to give us tan theta. So which means that for an inclined surface, if you are going to look for the coefficient of friction, don't go solving through a long process. Just look for tan of the angle it inclines with to the horizontal. So nu for inclined surface can be taken as tan of that angle of inclination. And then the force acting parallel to the surface will be W sine theta. Don't forget also that W is weight, which is, since W is weight is mg. You can also have it as mg sine theta. So aside that, R, which is our normal reaction, is also W cos theta. Since it's W cos theta, W also can be replaced with mg sine theta. So you can have it this way. So look at next, let's try to apply what I have just explained here. Look at this question now. So a block of wood weighing 4 Newton. So from this question now, the first part of the question has given us the weight of the wood. So you asterisk it, we are given the weight, that is 4 Newton. Is placed on a horizontal table. Since it is horizontal, you remember from what I said that once it is horizontal, we are going to use F equals to nu R. But once it is inclined, your F becomes mg sin theta and your R becomes mg cos theta. So it is then pulled by means of a spring balance. Then take note, spring balance measures weight, and weight is a form of force. So whatever information you have as for spring balance can also work as force. So attached to its end, the block just begins to move. Look at that part of the statement underlined. Just begins to move when the spring barrier records a horizontal force of 2.5 Newton. So from that statement that it just begins to move, it means that if the force is not up to 2.5, that block will not move. So if that block will not move, it means there's nothing we are going to calculate. So for the horizontal force to be 2.5, the block will just move. So the applied force now is taken as 2.5 Newton. So from here, the first question is telling us to calculate the coefficient of static friction, because it said just begins to move. So it's just leaving a static position, it's not moving yet. So in this case, our coefficient of friction is given as nu, which is F over R. Since that is given, what is the value of F? F is 2.5 over 4. So since we are going to have 2.5 over 4, if we divide this value, you have 0.628. Now, that is for the first part of the question. The second part says that what happens when a horizontal force of 2 Newton is recorded by the spring balance? When the spring balance decides to measure 2.0 Newton, NECO or WAEC can ask you to mention 2 or 3 quantities that don't have unit in physics. Don't forget, velocity ratio does not have unit. Mechanical advantage does not have unit. Stress does not have unit. Relative density also does not have unit. So also, this coefficient of friction does not have unit, because what you are dividing, they have the same unit, so they cancel out. That's why you're having 0.625 here as your final answer. The second part asks, what happened when a horizontal force of 2.0 Newton is recorded by the spring balance? Now look at it. When a horizontal force of 2.0 Newton, let's look at the question again. For this block to move, it requires 2.5 Newton. So it will not move if a force of less than 2.5 Newton is acting. So if somebody else now comes and is applying a force of 2 Newton, you're just wasting your time, because nothing will happen. So that's why you're having this answer. When the force is 2 Newton, the block will not move. There's a reason. Because the applied force is less than the limiting frictional force. It's like you want to buy bread in the market. You go, the bread is sold for 100 naira. You now get there, you are now presenting 80 naira. There's no way you can get the bread. That's just it. So you have the force that will make the object to move is 2.5. And now you are applying 2.0. It will not move. So you get that. Let's go. All right, so let's look at example number 2. A wooden block of mass 15 kilogram. Let's look at this. Mass 15 kilograms, so which means that the mass is given as 15 kilograms. So M is equals to 15 kg. A horizontal force of 45 newtons. So here we have force as 45 newton. And they said it's just sufficient to make it slide across the surface. Calculate the coefficient of friction. So from here, coefficient of friction, the formula is that coefficient of friction is force over normal reaction. The force here is 45. The value of normal reaction is not given. So once the value of normal reaction is not given, you look at it. What's the definition of normal reaction? That is mg. So the value of m is given as 15, and the value of g is given as 9.8. So you will now bring it 15 times 9.8. 15 times 9.8 will give us 147. 147. So from here, you're going to have 45 newton over 147 newton. So you look at it here, 45 over 147 will give us 0.306. To the decimal place, you're going to have 0.31. So you look at this, Newton cancels Newton. So which means that coefficient of friction does not have unit. Coefficient of friction is not the only quantity in physics that don't have unit. You can be asked in your theory that list 2 or 3 quantities in physics that don't have unit. So when you are saying it, you remember that relative density does not have unit also. Not only that, mechanical advantage does not have unit, velocity ratio does not have unit, tensile strain also does not have unit. So take note of all of these in case you are asked in your theory part for quantities that don't have unit. So coming back to what we are doing, coefficient of friction here can be approximately said to be 0.31. Let's go to the next question now. So the next question, looking at it, a block of mass 25 kilogram was made to slide on a rough horizontal ground. You can see all along we have been looking at horizontal. So I'm going to give you a case of having it to be inclined. Now a block of mass of 25 kilograms. So the mass here is given as 25 kilograms. So mass is 25 kilograms. To slide on a rough horizontal ground, if the coefficient of friction is 0.48, so nu is given as 0.48. So in that case, you're going to have it this way. The mass is given here. So your normal reaction is needed. Why? Because F equals to nu R. So we have our nu given as 0.48. The value of normal reaction is not given. If it's not given, we can get it. That's by multiplying mass times acceleration due to gravity. Mass given is 25, then acceleration due to gravity given is 10. So when you now say 25 times 10, you're going to have 250. So 0.48 times 250 will give us 120. So that's how you get 120 here. Perhaps if you are giving it to be inclined on a surface, so if you have it this way, if there is a force, if there is an object, a mass resting on the surface, looking at it, if it is inclined at an angle theta to the horizontal, if theta is 30 degrees, they can ask you what's the coefficient of the friction of frictional force, even if the weight is given, like let's say the weight is 25 kg, the mass is 25 kg, and you have the force here, you have the normal reaction here. This is going to be mg cos theta, and you're going to have this one as mg sin theta. So if you are asked for normal for the coefficient of friction, all you just need is nu is going to be tan 30. So whenever you are having it inclined to the surface, the value of coefficient of friction is always tan of that angle. So if you have it again, if the angle of inclination is, let's say, 45, your coefficient of friction nu will be equal to tan 45. If the angle of inclination, let's say it is 62 degrees, then you are going to have it as nu to be equal to tan 62 degrees. So let me say something, that as the angle of inclination here is increasing, the value of coefficient of frictional force will reduce. Let's take for instance, if you have an inclined surface, the lower it is, that is the smaller the angle of inclination. You will see that it will take a longer time for that object to slide down. But if it is higher, the angle of inclination is bigger. Once you drop the object here, immediately the object will drop down. So what we deduce from there is that once the angle of inclination increases, coefficient of the frictional force reduces. So angle of inclination will reduce the effect of friction for inclined surfaces. Now, I have some questions for you that I want you to go through. So I'll be giving you like 1 minute to go through this. Then I'll come back for the solution to the question. let's see what is the solution to this question. Look at question number 1. Question number 1, what is the coefficient of static friction between a load of mass 2 kg and a horizontal surface if the limiting frictional force is 10 Newton? So from here, given that the frictional force is 10 Newton, and then for coefficient of friction, you know that you have F over R. So what is the value of F? The value of F here is 10. What's the value of R? It's not given directly, but you know that R is defined as mass times acceleration due to gravity. Mass is 2, acceleration due to gravity is 10. So this gives us 20. So you're going to have 10 over 20. By the time you divide 10 by 20, you're going to have 0.5. So the correct option here is option D for this question. Let's look at the second question. The second question here, a metal block of mass 5 kg lies on a rough horizontal platform. If a horizontal force of 8 Newton is applied, now the question is that calculate the coefficient of limiting friction between the block and the platform. So from here, you know that coefficient of friction is from F equals to nu R. Then nu is F over R. What is F? The value of F is given as 8 Newton. Then you look at the value of R. The value of R, you can get it from mg. M is 5, yg is given as 10. So from here now, 5 times 10 will give us 50. So we can now say nu is F over R, which is equals to 8 over 50. So from here now, we see that the value of 8 over 50 is 0.16. 0.16 is option A. So the correct option now is option A. So that's the correct answer to this question. So for further questions, observation, comment, you can reach us on the social media handle that will be displayed on the screen. Thank you.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.